going to talk about the concentration of ions in solution. We have already done concentration of compounds in solution, so we figured out concentration. There were two different equations that we used. One was molarity is equal to moles of solute over liters of solution. And the other one was our dilution equation, which was M1V1 is equal to M2V2. And that works perfectly for a solution. Now, if we're doing concentration of ions, we know that the compounds break apart, whether they dissociate or whether they ionize in solution. And we have to take into account the number of ions that will be present if we want to figure out the concentration of each individual ion. So let's look at an example problem. It says determine the concentration of all ions in a 0.75 molar K3N solution. So what you're going to have to do here is first figure out where your ions are. So we have K3N, and we're going to have to write the dissociation equation for it. So we have K plus N minus 3, and we have to balance out our equation. So we have 3K plus. So for each K3N put into solution, we get 3K plus ions and 1 N minus 3 ion. So if we want to know the concentration of these ions now, we have to take into account the number of moles of each of them that is being produced. So we're starting with 0.75 molar K3N, and we want to know the concentration of our K plus ion. We're going to say 3 moles of K plus are produced for every 1 mole of K3N that's put into solution. So then the concentration is going to be triple. The concentration of our potassium ion is going to be triple that of our K3N. So what you're going to have to do is multiply 0.75 times 3, and you're going to end up with 2.25 molar K plus. Now if we were using our significant figures here, it would turn out to be 2.3 molar K plus. Now it asks for all ions. So we already figured out our K plus, now we want to do our N minus. So we have 0.75 molar K3N. We want to convert that now to the concentration of nitride. So for every K3N that is put in, we produce 1 mole of nitride. So here it's going to be a 1-to-1 ratio. So we're going to have the same concentration of nitrogen ion as we do as our solution. Now this example is a little bit more tricky. It says determine the number of moles of each ion in a 1.25 molar BaCl2 solution with a volume of 600 milliliters. So now we're not being asked for the concentration, but instead the number of moles. So we know that we can use our molarity equation to solve for moles if we're given 1.25 molar and a volume. So we're going to have to use molarity is equal to moles over liters. Now before we actually start plugging numbers in, we have to figure out what our equation is. I'm just going to write it above to save a little bit space. So we have BaCl2. And it has to break down into ions, and it's going to break down into Ba plus 2 plus 2Cl minus. Okay, so now we're going to try to solve for moles. So we have to multiply our molarity times our volume. And again, our volume has to be in liters. So we're going to have 1.25 molar times 0.600 liters. And that's going to give us 0.750 moles of BaCl2. Now that we have the moles of a BaCl2, we can do the same exact thing that we did above. You start off with 0.75 moles of BaCl2. It will create 1 mole of Ba plus 2 for every 1 mole of BaCl2 that's inputted, and we'll produce 2 chlorine ions for every 1 mole of BaCl2 that's put into solution. So we're going to have to do a conversion factor. I hope that you can see this. So first let's convert to barium. And that mole quantity is going to be the same because it's in a 1-to-1 ratio. And then if we do our chlorine, for every 1 mole of BaCl2 that's inputted, we get 2 moles of chlorine. So it's going to multiply our concentration by 2. So we're going to end up with 1.50 molar Cl-.